So it's time to learn about distance versus time graphs and what they can tell us. A distance versus time graph is obviously a graph of distance on the y-axis and time on the x. It's important that we have those in the right positions. Whenever you look at a distance versus time graph, keep in mind that you're trying to figure out what happens to distance as time goes by. Don't make it more complicated than it is. Whatever the distance is doing over time is what we're seeing on the graph. For instance, in this graph, you'll notice that as time goes by, the distance is staying the same. We have whatever distance this is, maybe 5, and it's 5 still here, and it's 5 still here. If the distance is staying the same over time, what does that tell us about the object? Well, that tells us that the object must be at rest. If the object is at rest, then we know its velocity is equal to 0. So whenever you see a distance versus time graph with a horizontal line like this, you know that the object is at rest, its velocity is 0. Now the question is, what does the position of that line tell us? Well, you notice that there is a 0 down here, so therefore these numbers up here are positive distances, so therefore this graph tells us that this object has a positive distance. Or in other words, it is at rest to the right of the origin. What that means is it's at rest with positive distance values, to the right of the origin. I cannot write and talk at the same time. So there you go. So this graph represents at rest to the right of the origin. This graph, on the other hand, is still at rest. How do I know it's at rest? Of course I know it's at rest because it's a horizontal line. The distance is not changing over time. You have the same value no matter where we are on the time axis. And what is that value? Well, it happens to be down here at the 0. So therefore, this object is at rest, but it is at rest at the origin. In other words, it's at 0, position 0. That's what origin means. So this one is at rest at the origin, at rest at a distance of d equals 0. Okay? If you understood those two, you should be able to tell me what this one means. Uh-oh, there's a mistake on here. I need to get rid of this 0 down here. This 0 should have been put right here. So if 0 is in that position, what must be the location of this object? Well, we know it's at rest again. How do we know it's at rest? Because it's a horizontal line, but the question is, where is it at rest? Because this is going to be a negative value, it's at rest to the left of the origin. Or in other words, it's at rest with a negative distance. Questions? Cool. So whenever you have a horizontal line in a graph like this, it tells you the object is at rest. And the position of that line tells you where it's at rest. Now in this graph, the line is no longer horizontal. It's still a straight line, but it is at an angle. It's diagonal. When that happens, we now have an object that is moving. Because if you think about it, if this was its position at a certain time, and twice that time later it's now this far away, and twice as later it's this far away again, as you continue to move farther away, or continue to move along in time, it's moving farther away. So obviously this object is now moving. The way it works out is because it is a straight line, it is moving at a constant speed. Because the slope of this line is positive, we will say this has a constant positive velocity. In other words, it has a constant velocity moving to the right. That's what a constant positive velocity would be. What do you think this one is going to mean? Well, first of all, we have a straight line. Straight line tells us that we again have a constant velocity. But notice now the slope of that line is downward, like this. If the slope is downward, then it's no longer a positive velocity. Instead, we now have a constant negative velocity because the slope is negative. So whenever you have a distance versus time graph where you have a diagonal line, you know that you have a constant velocity. Actually, when you have a distance versus time graph with any straight line, you know you have a constant velocity. If the line happens to be horizontal, it's a velocity of 0. If the line has a positive slope, it's a positive velocity. If it has a negative slope, it's a negative velocity. Now we introduce a curve to our distance versus time graphs. Notice with these graphs, if I were to draw a tangent to the curve, at this point it has this slant, at this point it has this slant, and at this point up here it has this slant. What do you notice about the slope of that line? Well, do you see how it's getting steeper and steeper? If it's getting steeper and steeper, that means the velocity is increasing. If the velocity is increasing, that means we have a positive acceleration. Whoops, positive acceleration. So whenever you see a curved distance versus time graph, you always know that it means acceleration. If it's curving upward like this, that's a positive acceleration. This is also a positive acceleration. You may say, how do we know that? Well, here is the slope of the tangent here, so it's got a steep negative slope. Here is the slope of the tangent later. It's got a less steep negative slope. Here it's got a very unsteep negative slope. So the slope is getting less and less steep, and it's moving in a negative direction. So that means that you have to have a positive acceleration if you're going to have a negative velocity that's getting smaller. Because remember, if something is slowing down, its acceleration is the opposite direction as its velocity. So this has a negative velocity, so therefore it has a positive acceleration. So this graph represents, whoops, this is a changing negative velocity, sorry. So that, therefore we have a positive acceleration. It has a decreasing negative velocity, so it has a positive acceleration. That is in contrast with this one, where again we have a negative velocity. See how the slope is downward. But as I move along this curve, the slope gets steeper and steeper. That means I have a negative velocity and I have an increasing negative velocity. So therefore I must have a negative acceleration. If it's got a negative velocity and that negative velocity value is increasing, it's a negative acceleration. This is also negative acceleration. Now I have a positive velocity, but that positive velocity is diminishing. If the positive velocity is getting less, in other words, I have a decreasing positive velocity, that means I must have a negative acceleration. Because if the velocity is getting less, that means the acceleration is in the opposite direction. Here is a key concept that you need to write down. Oh, look, the note there means put it in your notes. If I'm going to find the slope of this line, remember slope equals change in y over change in x. Some of you keep putting that backwards. The change in y goes on top. In this case, the y is this one. This is our change in y, which happens to be this axis, so that is a change in d. Then our change in x is this axis, so that's the same thing as change in t. So I'm going to put that in up here. In place of delta y, I'm going to put delta d. And in place of delta x, I'm going to put delta t. Well, what is d over t equal to? Well, that's the speed. So therefore, the slope of this line is telling us the speed of the object. Slope equals speed. We already talked about that earlier. I said if a horizontal line has no slope, no velocity, a line at an angle is going to have either a positive velocity or negative velocity, depending on if it has a positive or negative slope. So I'm just reiterating that. Now understand, you could actually calculate the speed from this graph. For instance, if this value here was 3 and this value up here was 8, these would be in meters, let's say, and this value down here was 4 and this value right here was 1, and this would be in seconds, then to get the slope, I do the change in y, which would be 8 minus 3 meters, divided by the change in x, which would be the 4 minus 1 second. So that gives me 5 over 3, 5 meters over 3 seconds, which is 1.67 meters per second. Get it? Isn't that cool? So I can actually find the slope from this graph. And that is all you need to know about distance versus time graphs. You need to know the shapes. The horizontal lines mean at rest, and the position of that line means where. You know, the diagonal lines mean constant velocity. If it's a positive slope, it's constant positive velocity. If it's a negative slope, it's constant negative velocity. And the curves mean acceleration. And the slope of the line is equal to the velocity of the object. Any questions? You'll have to ask me later. Jot them down so you can ask me when you see me in class. Thanks. Toodles.